up here, and I want you to tell me the difference. So if I said to you, x equals 5, wouldn't that mean the solution is 5? Is the solution 6? No. Is the solution 8.5? No. Okay. Let me write it as an inequality. This is one number. Okay. Let's say I said the solution is x has to be greater than 5. Okay. That means now I have a whole slew of answers, doesn't it? So give me some examples. What would be a solution to that? 6, 10, 1,000, 5.5. Now, in fact, the number 5 would not be a solution to that, right? Because this is saying it's got to be greater than 5. So a linear inequality is kind of the same deal. It's not just a line, it's going to be a region, okay? So what I'm going to tell you today is when we solve these things, you're not going to get a number, okay? You're going to get a boundary line and shaded region. And so the solution is going to be any point in that region. Okay, so we are going to have two kinds of boundary lines. I'm trying to find a better pen, sorry. This one's too thick. I need new pens. Nobody got me any for Christmas, Grayson. Where was my Christmas present? Remember in elementary school when you'd get your teacher Christmas presents? Why do you stop in high school? Huh? Just give it to your math teacher. That's the only one that counts. Then she'll like you a little more. Look at these pens. I don't have any. I'm running out. Write that down. Precise V5s if you want to get on my good side. All right. Boundary lines. There's two kinds. Draw a solid line, please. If the inequality includes the boundary line, meaning that the solutions can also lie on the boundary line, that's going to be when you see this symbol. What do those little lines mean under the inequality? Or equal to. So if you see an or equal to, that means that the solution can lie on the line and in the shaded region. We're going to also do a dashed line today. The dashed line we're going to use when we have just a less than or greater than symbol, and the reason why is because the line isn't included in the answer, and so we show that with a dash. It goes right up to, but it doesn't include it. Okay. Right next to this, I have a picture of what it looks like. So do you see the boundary line right here? And do you see the shaded region? All right, would you find for me a point that would be a solution to that? There's lots of different answers. Find a point that's in that region, okay? Just put a big dot on it, wherever you want. In the region though, it's got to be in the shaded region. Would you talk with somebody around you and just double check that you know what that means? Antonio? Come on, you can do this. Okay, Kanan, Kamari, Birdie, what'd you guys come up with? All right, they said 0, 2. That is a solution because it is in the shaded region. Grayson, what'd you guys come up with? 0, 0 in the region. Haley? 6, negative 2. Okay. you're not going to list them all because there's an infinite. They go forever. So we just use a region to describe them. All right, let's try one. Well, first of all, let's decide if it's a solution or not, okay? How we check if it's a solution is we're going to plug the point in, and we're going to see, does it make the inequality true? So I have my pen on this. Is this an x value or y value? So I'm going to plug it in for x. Is this an x value or y value? Okay, so let's go ahead and plug those in, or replace them in for x and y. And I'm going to write this out here. I'm checking, does this make this inequality true? Okay, what is 3 times negative 2? Negative 6 plus 20 is 14 is greater than 8. That is true. 14 is greater than 8. The answer is yes. Okay. Would you guys check this one for me a minute on your own? Ooh, be careful. There's no bar under there. Okay, are you with me so far? A negative times a negative is positive. 6 plus 10. Okay, think guys. I know that's the same number, but think about this. Is this true? Is 16 less than 16? No. All right, here's some standardized test language. Not because I want to ask questions like this, but you're going to get asked a question like this if you take the PSAT or SAT. And I just want you to see what it looks like, so you're not, it looks weird. Whoa, which of these following order pairs satisfies, that just means makes true, okay, the inequality. Let's check them out. And what we're going to do is we're going to go one by one, and if it is a yes, let's put a check mark by it, okay? Let's check 5-1. Okay, is 20 minus 7 greater than 5? Okay, put a check mark by number 1. Let's check 3-4. Is 12 minus 28 greater than 5? No. What's 12 minus 28? It's a negative number. Okay, we're going to put an X. That is not true. Let's check the last one. Ugh. Too many negatives. What in the world? Okay. I'm going to have to write this one out a little bit because it's a little tricky with all the negatives. This is negative 4, but then I have 2 negatives here. So what does that mean this changes to? Positive 21. Is negative 4 plus 21 greater than 5? It is. Okay, it looks like 1 and 3 work. Let's select the best answer. It should be letter D. Okay, so that's how you check if an inequality is true. Now let's graph it. Some of you struggle with graphing, so here's another opportunity to brush up on that. So we're going to graph the boundary line. We're going to, like we did before, okay? The only difference is you're going to either make it solid or dashed. Okay, but then we have to decide where to shade, right? So I'm going to show you how you can put a little point in like this and decide where to shade. Let's look across. If this were an equal sign, this is in slope-intercept form, correct? What is the y-intercept? 1. Would you put the 1 on the y-axis, please? Okay, next. What's the slope? -2. Tell me what to do. Go down 2 over 1. Before we make our line, let's decide, is it dashed or solid based on what we said above? Look above what we wrote. Is it dashed or solid? It's dashed because it's a less than symbol, isn't it? Okay. All right, so I'm going to go down 2 over 1. I'm going to do that a couple times. I am going to get my straight edge, which is just this little cardboard thing here. And I'm going to make it a dashed line. Okay, so here's the deal. When you have a line, there's only 2 choices for shading. Either I'm going to shade over here, or I'm going to shade over here. So what we do to decide that is we test an easy point and we see if it's in the solution. And you know what the easiest point to test is? 0, 0. Do you see 0, 0 is where I just highlighted? It's below the line. So if I put 0, 0 and it makes it true, this is where I'm going to shade. Okay? If it doesn't make it true, then I have to shade on the other side. The nice thing is there's only 2 choices. Either it's on this side or that side. All right. So I have this point 0, 0, and I'm going to plug it in up here. Is 0 less than -2 times 0 plus 1? I'm going to tell you guys after I just now, after this, I'm not going to write this anymore. The whole reason of me picking 0, 0 is it makes things cancel out and it's nice. What's -2 times 0? 0. Okay, so this really is 0 less than 1? Is that true? Yes. So 0, 0 is in the solution. What that means is the solution has to be down here. Shade below the line. I'm going to shade with the highlighter. You can just shade with your pen or pencil. So anything in that region would be the solution. Okay, let's do one more and then I'm going to have you guys try one, okay? Ooh, yeah, we should do one in standard form. Okay. Some of you like to rearrange things when they're in standard form. We're getting to a point now, like this is the 3rd time we've talked about this. I'm going to use intercepts to graph this. Plug 0 in for x. Somebody tell me I need an intercept for that. Use your calculator. If this is 0, then I have to graph the line. I know it's not an equal, but when I graph the line, I pretend it is. I get that. What's y equal? -1.5. Thank you, Bertie. I put 0 in for y. Cancels that. I get 2x equals -6. What's x equal? Okay. Would you please plot those 2 points on your graph? So 0, -1.5. And -3, 0. Oops. Okay. Let's look at this. Is this solid or dashed? Solid. So connect this with a solid line. Now this is the last thing. This is the thing people forget. They're like, oh, I can't remember how to do this. We need to shade on one of the sides. So the last thing we do is we test a point. I always like to test, which one? 0, 0. Now here's the deal. If the line goes through 0, 0, you have to pick something else. But does this one go through 0, 0? Nope. Let's circle 0, 0. It's right there. It's above the line. Let's test it. Two times 0 is 0. 4 times 0 is 0. Is 0 greater than or equal to -6? It is. It's not, if it were positive 6, it isn't, but 0 is greater than -6. That means 0, 0 is a solution. I'm going to shade on the side that 0, 0 lies, so up here. Okay. I would like you to try this one, please. I just did 2 of them. Uh-oh, what am I missing in there? The x. Put a little x in there, would ya? Y is greater than -4/5 x plus 2. Would you guys see if you can do that one on your own?